Hello, folks. Welcome. Thank you so much for being here. Really excited for today's webinar, which I think is super relevant to the state of our world today. So we're going to be talking about wildfires on a warming planet and specifically looking at factors that would lead to enhanced fire risk, as well as the forecast for the next to the end of the year and beyond. So just a quick introduction of who I am. So my name is Dr. Hansi Singh. I'm an Earth System scientist. I formerly worked at the U.S. Department of Energy. I was also an academic for a while, a professor. I still contribute a little bit to Earth System model development at NCAR via the CESM. They have several working groups there, and I work particularly on ocean and ice factors. And so the reason why I started Planet was very particularly because I wanted to bring some of that awesome knowledge from the research world where there's just a ton of smart people, but often we just talk among ourselves and geek out over science, and the real world where we can actually take this information and help people make better decisions, specifically as our planet becomes warmer, the weather becomes less expected, environmental information becomes really necessary for adaptation and resilience. So just a quick announcement. We are currently have received a nod from the U.S. Department of Energy's Genesis mission, specifically to lead a initiative on severe convective weather. So that comes into play here because remember, a lot of the ignitions with wildfires are due to such weather. I'm not going to talk too much about ignitions from thunderstorms in this particular presentation. But stay tuned because we will be talking a lot more about this because these are just such important events for wildfires as well as generally for mayhem and property destruction and, just dangerous weather all across our country and in many parts of the world. So wildfires. Today, I'm going to talk about the science of wildfires. From there, I'm going to talk a bit about changes in wildfire activity that maybe, anecdotally we all notice and sort of what has caused that. Climate change is part of the answer. It is not all the answer. So it's really important to kind of look at the entire picture here. And then from there, I'm going to focus on the coming Super El Niño and its implications for fire weather, or sorry, not fire weather, wildfire prone conditions over the next 6 months and beyond. So I probably don't need to say this with folks that are here today, but weather is really central to wildfire risk. So weather provides the backdrop for excess precipitation that allows vegetation to grow. Then it also provides the backdrop of heat and drought that allows this vegetation and soil to dry out. And then, of course, with lightning for ignition and winds for spread, we then once again are at the mercy of weather. And just keep in mind, obviously, with ignitions, humans do all sorts of crazy things like, throw a burning car off of a ravine, for example. That is like a real thing that has caused major fires. But just in general, I mean, this tends to be the cycle of how fires are given the right conditions for starting and then start and spread. So the big kind of weather groundwork that is laid is specifically dry vegetation. So in order to have ideal conditions for wildfire risk, we need initially wet conditions so that we can just get abundant vegetation growth. This creates fuel for fires. And then followed by that, we need these kind of hot and dry conditions that are able to dry out brush and make it flammable. And so these two factors together, one after the other, really are what allow conditions to be optimal for fire. And this also explains why fires occur in some areas and not others. So some areas are fuel limited, meaning that there's just not anything here that's going to burn. And then other areas are flammability limited. This means that there's a ton that could burn, but it's very wet. And so if you can't get this fuel to become flammable, then you're not going to get fires. So fire weather then, against this backdrop of this sort of dry vegetation, dry soils, fire weather specifically combines high temperatures, dry conditions, specifically low humidity, as well as soils and vegetation that are already dry, in other words, fuels that are flammable, and then winds, as well as possibly ignitions through lightning, can then create conditions that are optimal for the ignition and the spread of fires. So this is just overall how we think about specifically conditions that can suddenly give rise to a whole bunch of fires, specifically because this is for ignition and spread, but we do need the backdrop of that really dry vegetation in order for fire weather to actually matter, for fires to actually start. So climate change does exacerbate these factors. So first of all, with climate change, we often get very intense, short wet seasons. And these wet seasons, in some areas are wetter. And so a wetter wet season can lead often to vegetation overgrowth. So we have this vegetation overgrowth, and then from that overgrowth, well, we have a long dry season. Temperatures are high, and over time, the high temperatures lead to high evaporative demand from the soils, from the excess vegetation. And so we end up just drying everything out. You might have noticed if you've gone through like a recent heat wave, if you start to look at vegetation before and after that heat wave, you'll really notice the effect of like just high temperatures and that high evaporative demand that results from them. And so this is how we get soils and vegetation that are just primed, in other words, flammable fuel for fire weather conditions to then start and spread fires. So wildfires are on the rise as our planet warms, but this isn't really the whole story. So this is a picture of a graph from NASA, specifically on burned area in acres in the US from 1983 to 2025. So there is this like upward trend. There's definitely some years that are much more mellow and some years that are much more intense. And so, by looking at this, you might be like, yeah, this is all climate change. It's not all climate change. So there's a lot of intervening factors here. So first of all, we are coming out of just decades of fire suppression activity in our country. So very particularly, we have had various types of incentives and encouragement, and to tell people, well, no forest fires, zero, right? You're not allowed to burn anything. Well, the problem with that approach is that flammable fuels have built up. And so those flammable fuels, the way that you get rid of them is through fires. And so right now, many of our forests are just primed to burn once fire weather conditions develop. The second issue here is an increase in settlement at what is called the WUI, or the wildland urban interface. So very particularly the WUI, it situates humans very close to wildlands. And these wildlands in particular are wildfire prone. And so it is often very easy for, our buildings and structures to get caught up in wildfires. And it also puts us right in an area where anything that we ignite, either purposefully or accidentally, like for example, just imagine, a power line that starts sparking because there's high winds. Now it's just in an area that is primed to burn. So it's not just a house or two that burns, but it is then, this entire region that is primed. So these are sort of a couple of factors that have almost certainly led to some of the increase in area burned over the last couple of decades. It's also important to remember from a global perspective that not all large fires are wildfires. So sometimes if you look at like a global map of fire burned area, you'll see some peak years. And those peak years, some of them are just from deforestation, like a country decided that this was the time to clear out a bunch of forest for farmland. And so the way that they did it is literally through fires. So deforestation is a huge contributor. Another huge contributor is also clearing of cropland. So this is also important to sort of disambiguate. And sometimes these fires, which are used to clear cropland, if conditions, are right, say there's a lot of flammable fuel and maybe there's some wind, specifically, good fire weather for spread, these can get out of control. So something that started innocently in this way, becomes a wildfire that then needs to be dealt with. So this year, you might have heard and been seeing in the news, it is a very active fire season in some locations, specifically in the Western US, away from coastal regions, and over Europe, which is probably feels a little bit surprising. So there's a few reasons for this. First of all, in many areas, we either dealt with a drier than usual winter season, like in Europe. And by the way, this is one of those things that does show up on forecasts. So we can actually like see these drier than usual winter season conditions. If you look at some of my old webinars, I'm like, oh, Europe looks like it's really dry. So, or it's going to be really dry. So this is actually something that we can anticipate, which is great. And the other thing that we often see is less snowpack. So even if we got enough rain, maybe we don't have snowpack, which is our big bank of water. And snowpack is like the gift that keeps giving. So, if there's a lot of snow, then over time we get a lot of runoff, and then that runoff helps sort of keep everything, just a bit less flammable than it would be otherwise. So these are some of the conditions that we dealt with in the American West, specifically less snowpack, in Europe, drier than usual conditions. And then combining that with a warmer than usual spring and summer with low humidity. And then combining that with sort of periodic just fire weather conditions that, for a few days, it's like hot and dry and windy. And there you go, perfect conditions for starting a ton of fires. And so this gets me to something important, which is that, we can use long range forecasting to anticipate wildfire risk. We can look at temperatures, we can look at the cumulative rainfall as well as snowpack. We can also look at the humidity of the atmosphere. And then, at shorter lead times, weeks to days, we can also take a look at near surface winds. We can also look at the possibility of severe convective weather, thunderstorms, in other words, that could lead to ignitions. So all of this stuff is stuff that can be predicted, and some of it can be predicted like months early, many of these things. Wind episodes, you need to wait for sort of closer, so weeks to days, but the groundwork we can predict quite early. So before I get into some forecasting, just kind of a quick intro of how long-range weather forecasting works. So when we forecast weather beyond the 7-day weather window, or the 14-day weather window, if you want to think of it that way, we use weather models. For anything beyond, those 14 days, we really need Earth system models. So weather models are atmosphere only models. Our atmosphere loses memory, forgets about where it started from in about 14 days. But there are other components of the Earth system, like oceans, ice, land, that have much longer memory. And so this allows us to make predictions and projections from weeks to years to centuries, even. These are our climate models. So if you look at climate projections, this is what you're looking at. But this is also what we use for long-range forecasting. Note that we cannot tell you a particular day that a hurricane will hit 6 months from now at a particular location, but we can tell you something like, for example, hurricane risk at that time based on fundamental factors that lead to the genesis of hurricanes, for example, as well as their movement through the atmosphere. So I want to begin just by kind of showing some forecasts in the real world and kind of how powerful they can be. So you might remember these fires in Hawaii in August 2023. So this is something that these are fires that were predicted from forecasts or conditions, I should say, be very careful with that. Conditions conducive to these fires showed up in forecasts. So in particular, the priming for these fires was vegetation overgrowth early that year. So February, March, April. You can see that, the islands got a ton of rain, and our forecasts also predicted a ton of rain at that time. And these were forecasts. These are the seasonal forecasts. So these are 6 months ahead forecasts that showed excess rainfall. And then once again, 6 month ahead forecasts showed that for July, August, and September, conditions were going to be significantly drier than normal. So this is just kind of one of the ways in which, we can really understand how weather sort of primes conditions for wildfire risk to be elevated at a particular region, at a particular time, at a particular fire season. Here is a prediction of rainfall preceding the Los Angeles, California fires in January 2025. So this particularly is looking at the rainfall, and this was a prediction made in June 2024, looking at the rainfall in October, November, and December. And so usually the rainfall is up here, and this is what the forecast said the rainfall would be. So very high likelihood that it would be much less rainfall than usual. And then this is where the actual fell right here. And so, these once again are the conditions that are the groundwork for creating wildfire prone lands when fire season gets here. So now let's start looking ahead at the forecast. As we all probably know by now, we have an El Niño. It's strengthening. It's very likely to be record breaking, and it is going to be a major driver of wildfire risk over this next year. So there are some important impacts of El Niño on wildfire risk. In some regions, El Niño causes anomalous warm and dry conditions. So this is perfect for turning excess vegetation into flammable fuel. And, the coming fire season is going to be a wild one. The other possibility is that El Niño creates wetter than usual conditions. And so often, these are wetter than usual anomalous conditions. So that you end up with this sort of vegetation overgrowth situation. And by doing that, you're setting the stage for not this fire season, but the following year's fire season. So now let's look at some specific regions where fire risk is elevated. So here, what we're looking at is the forecast for Southeast Asia and Oceania. And this is an area where, wildfires are already spreading. And this is something, it's like so canonically El Nino. This is something that was showing up in forecasts like literally in January. It's like so dramatic that you see these effects of El Nino on precipitation in this region. So this is an area that unfortunately, until the end of the year, is going to be very susceptible to wildfires, low water levels that are going to impact many industries as well as transportation. So yeah, very clear and robust impacts expected here. Another area to really keep an eye on is East Australia. So in particular, this is showing the sort of over the last year, how much rainfall this region has had relative to previous years. And you can see that this area right now is in a drought because there's a significant rainfall deficit. So Central Australia is doing pretty well, but not East Australia. And so if you take a look at forecasts, what we see is that over the next several months, this area is going to continue to receive much lower than usual rainfall. And so, yeah, this is going to be an area once again, if you remember some of the wildfire seasons from Australia in particular, this is a region that is very prone to wildfire, and the stage is being set for another active wildfire season through the end of the year. And hopefully, January and February, they will get a lot of rain and, make up for some of this. But yeah, it is looking pretty dry for the next several months. Another area that is very fire prone is the Pacific Northwest. And very particularly, we expect that this region is going to be drier than usual and warmer than usual. Our fire season is usually over by October, when the rains start, but it's really going to depend on like when are those rains going to start. And so, you might see us doing rain chants or something. I don't know, because I know people are going to get desperate if we end up with a ton of smoke and a lot of fires, which we are already getting specifically inland. Um, and Oregon is already on fire, unfortunately. So in particular, another huge risk factor for this region has been the fact that reservoir levels are dwindling and we have very little snowpack to replenish those reservoirs. So these are sort of factors that can then, move us into this regime where fires are much more likely for the next couple months until rains resume. And note too, this is one of those years where it's unfortunately going to be possibly like, the gift that keeps giving. So, this coming winter, the wet season is supposed to be relatively dry in this region. And so what that means is then we are primed for next fire season to also potentially be dangerous. So, yeah, this is one of those sort of long range impacts of an El Nino. I've talked about this before, specifically, like, yeah, in many places we actually see economic impacts that stretch for decades, or not decades, but years from a particular El Nino event. And so, these are the kinds of longer term impacts that we tend to see due to the really major weather impacts that we see from an El Nino. Another area to really keep an eye on is Amazonas. So this region right here is going to be very dry through the end of the year, and that is when they usually get a lot of rain. So, your rainiest time of year is going to be dry. And keep in mind that the last time we had a Super El Nino, which was 23 to 24, we actually had a huge amount of forest loss. And this was not, intentional forest loss like, we have seen in this region, specifically deforestation for agriculture. No, this was not that. This was literally fires that are out of control over the Amazon. I know it seems crazy because we think of the Amazon as like so wet and so lush, but it will burn when we have years like this. And so, this is one of those risks where, once again, as we go into 2027, we are going to see the possibility of a lot of forest loss. And of course, then, people talk about carbon budgets. It's like, yeah, those forests were holding all that carbon on the ground and now it's in the atmosphere. So, once again, I mean, these are really compounding issues that come up when we have really active fire seasons due to a situation like this coming Super El Nino and past Super El Ninos. So speaking of compounding risks, the compounding risks here are not just risks that have to do with fires and when they start, but can also, happen when, say over a region that has had fires, we suddenly get heavy rainfall. So this is an awesome figure from Agakuchek et al. 2020, where they were looking at the situation specifically in California, where there were sort of major mudslides in 2018. And so what they did, they were sort of looking at, okay, what situation led to this? So, there was initially a drought. Then in 2014 to about, or sorry, 2016 to 17, there was a lot of rainfall. And then following that rainfall specifically, there was a lot of drying and wildfires. And from there, then when the rains came, suddenly hills that had been rendered hydrophobic from those burn scars suddenly became, really good at, instead of absorbing water, just, letting it wash down with a ton of debris. And so, unfortunately, like there were situations where many people died because of these mudslides that happened with heavy rains. So the point is that once again, the impacts of a major fire season don't just stop at that fire season, but they can be felt months to years after that fire season. So finally, I should point out that there are some areas, at least this fire season, where we're going to see decreased wildfire risk. So one area is specifically Chile near the Santiago region. This was kind of an interesting area because it is prone to fires. And I earlier this year I was talking to, some folks in Chile, and they were like, telling them, oh yeah, the forecast looks like a lot of rain for y'all. Are you ready? And they're like, yes, we love the rain because it's, so dry around here and we get all these fires. So yeah, they're getting the rain that they want. But just keep in mind, right? Rain creates vegetation. And so then when conditions are right, hot and dry, then that vegetation then becomes fuel for the next fire season. So this is something we've seen in the past in this region. So it's something to keep an eye out for specifically later in 2027 and even into 2028. California, we're going to be seeing something similar. So lots of rainfall at towards the end of this year. And then, from there, we can possibly expect decreased risk of fire activity this year, but increased risks in following years because you've now created a ton of vegetation. And then you possibly also are in some regions where there are burn scars. Yeah, there might be enhanced risks of landslides and flooding, just because, once again, fire really changes the characteristics of landscapes and makes them more prone to some of these other hazards once you add rain into the mix. All right, folks. So that's all I got for today. Thank you so much for being here. And just to let you know, we have a webinar coming up that specifically we are going to focus on the 6-month weather outlook for Central and South America. So really excited to go through that because it's quite dramatic. And thank you so much for being here. If you have any questions, please email us or yeah, get in touch with us and we'd be happy to answer them. And you can watch a ton of informative videos on YouTube. For example, if you're like, gosh, this El Nino, what is that? Well, we have a webinar on it. We have several webinars on it because it keeps on coming up. It's sort of the gift that keeps giving. And so, yeah, you can check out some of this really critical information because we are having a very weather busy year. All right, folks, thank you so much. And until next time, get in touch if you have any questions. Thank you so much.